Now I prepared a little presentation about Fronius history. Yeah, that's a little story or history. The roots, yeah, a brief overview of the roots of Fronius. And the beginning was, so our roots was with Günther Fronius. Yeah? Günther Fronius in 1945. He signed the above notice to opening the first chapter in the story of success that has continued to this day, now under the stewardship of the third generation of Günther's family. That was the beginning, and 20 June 1945. It all begins in a small town in Austria. It calls Pettenbach. It's a nice village, small village, and where our headquarters are still located today. Günther Fronius lives and works here after taking over an old military barracks as payment for some and repair work. It was a woods building and looks like a garage. And at the time it was always interesting to charging the car batteries. It was not a matter of course. He don't understand it always to put it down. When it's finished, he want to charging. That was the beginning. It's a picture from Günther Fronius and his wife Friedel. And he always said, you need knowledge, ability and desire, then you will achieve something in your life. That's a statement from Fronius. That's also from the interview from the year 2007. The growth of the year, this was the Transac, I think it was the year 1980, right? That was the first inverter power source. And here a picture from Klaus Fronius and Brigitte Strauss, looking at what the company has become, the latest generation, and we proud and happy. That's also from the interview from the 75 years Fronius, what we have. Shaping the future. In 2012, the patent was based on the next generation. Elisabeth Engelbrechts Müller-Strauss. It's the next generation. What we are and what we stand for is based on my grandfather's belief in sustainability. We remain committed to this sense of responsibility today. That's the third generation, Elisabeth Engelbrechts Müller-Strauss, now the CEO. The company, Elisabeth Engelbrechts Müller-Strauss, Langeder, Mr. Herndler and Mr. Lenzeder. That's the Fronius Management Board. Here detailed, CEO and CFO, Mr. Herndler, Mr. Harald Langeder and Mr. Volker Lenzeder. The facts and features, patents, export trade and countries, partners, international Fronius subsidiaries, facts and figures. Research and development department we have also in Wales. Yes. The next village is in Thalheim. We have more than 840 employers in R&D. That's here some testing the power sources and also here the vessel changer from the solar. Manufacturing we have also in Satlet. That's all villages in near from Wales, maybe I think 10 kilometers. Pettenbach, it's also made torches. That was the start from Günther Fronius at the old. This work is also now working. And then rebuilding Satlet and Wales. And Satlet is the manufacturing. Final assembly in Satlet, and then welding torches in Pettenbach. and the production transformers cables in Czech Republic. We have some business units, 3 business units, with perfect welding, solar energy and perfect charging. It's a pioneer perfect welding and solar providing solution for a sustainable future, and charging is balancing sustainability and efficiency. Perfect charging, founded in Bettenbach 1945, and providing smart and best-in TCO. TCO is total cost of ownerships. Perfect welding founded in 1950, innovation leader in welding technology. Solar energy founded in 1992, making 24 hours of sun, really. Yeah. Fronius Earth mission is also with the people, the planet and the profit. Unit perfect welding. We have a short video. That's the newest video. This video is to see some parts what we are welding from customers. Automotive customers. Yellow goose, we see all this looks like yellow. Heavy duty welding, high performance. Okay, then we have our global network. We have 24 subsidiaries, 58 representatives, North, Latin America, Middle East, Western Europe, Eastern Europe, and on the Pacific side, Asian side. Westcava, Western Europe, Scandinavia, Baltic states. We have almost 7 subsidiaries, 11 representatives, and 261 employers. CE, Eastern Europe, 4 subsidiaries, 12 representatives, 123 employers. North Latin America, you see Canada, USA, Mexico, Brazil, Argentina, That's the 5 subsidiaries, 8 representatives and 201 employers. Asia Pacific, 6, Japan, Hong Kong, Vietnam, Thailand, China, India. Subsidiaries, 11 representatives and 245 employers. Middle East, Africa, Central Asia, 2, Turkey and South Africa, 16 representatives and 37 employers. The milestones of the Fronius history is we started in 1960, first Fronius welding converter, 1980 first inverter, what you see on the picture, the Transac. 1998 digital revolution, transpulse synergic, fully digital controlled, 2001 laser hybrid. It's also a high performance welding process. 2004 the CMT process, dynamic cold metal transfer welding process. And then 2013 TPSI, the intelligent, from the digital to the TPSI, the intelligent. The I is standing for this. 2014 the Accu Pocket. Now it's the battery, the new one, the new name. Then we go also in the welding data management 2016. That's WeldCube intelligent. 2019 robot assistance system, wire sense, teach mode, touch sense. 2020 the trans steel pulse, 2022 DynamigWire, what we have here, and 2023 the welding simulator. With welding solution we have manually, robotic and mechanized, MIG-MAG standard pulse CMT, MMA, TIG and TIG plasma. Manual welding systems. We have the experience at the highest level, MIG-MAG and TIG and MMA, flexibility. On the robot side we have also TIG, TPSI, and on the TIG side we have different processes, Arctic, TIG and plasma. TPSI we have push, power drive and push-pull, that's for the robotic side. And also high performance welding TPSI twin push and TPSI laser hybrid and CMT twin. Also we have automation. We have FRV, the system, complete or handling to weld, handling robots, or also compact cobot cells. Hard automation, circular welder or seam welder, clamping, bench systems or circular welding. Also cladding is possible, cladding system. Here are different systems from the cladding side and also speed cladding to preheating the wire, and you can bring more wire on side on the cladding side. Products from the automation is orbital, carriage and from some components. The target segments from the automation, also general industry, yellow goods, automotive, what we see also in the video. Also customer tailored service are also important for the right data management or from the WPS welding training on the future, and also WeldCube software solutions, data interfaces. Here we have some links, stay in touch with us. That was a little history from the company. Then we go to the next step. I want to explain the function from DynamigWire. The introduction and definition of TIG DynamigWire is based on the active control on the wire feed. The actively iterating wire control expands the parameter window and simplifies handling. The wire feed speed is automatically adjusted to the amperage, arc length and the seam type. TIG DynamigWire works in synergic modes. We have all synergic characteristics possible for some different materials. Also aluminium, nickel base, steel. That's all synergic modes. There are individual characteristics for different wire diameters and alloys, and the fine-tuning of the wire feed speed can be used. We see it on the wire correction parameter. It's -10 to +10. It's only one parameter what you can use. The basic principle is only here we have a voltage can be measured from the arc and to the workpiece. On this side we always measure the voltage, and what you need is the print they're using existing in the ECR63. It's printed at the V volt. That's the measure point. Basic principle, okay, we're starting here with this point, the wire is coming. It's the first point. We are here completely stable on the voltage, wire feed, on the welding current and the arc voltage is coming. Then we have here on the second picture the contact with the workpiece. And now is go back with the wire feed speed. We don't need the wire is stopping. We have the arc voltage always stable. And the welding current is always the same. And the voltage between and the workpiece is also go down. Contact, the next step, stopping, wire feed and the voltage measurement from the V volt, from the print. And on the next, it's burn up from the arc voltage, the wire, and come the next wire. Synergic lines, what we have: aluminium, magnesium, aluminium, silicium, stainless steel, steel and titanium. And when some customer needs a specialist characteristic, then we made it for the customers. Only this button, DynamigWire, the process, use the process, and then use the filler material. It's a picture, how it works. Wire comes, contact, stopping, and waiting to burn. And always feeding, stopping, feeding, stopping. It's also possible with TIG DynamigWire pulse. And the wire correction is -5 to 0 and to +5. We see it here on the, after the seam we have here -5, that's meaning we became not so much wire. It's a little flat more. 0 is what we use for the synergic line, and on +5 we have more wire. Start stop with DynamigWire. We have here 2 mm, and here is the function out. I think we have here some videos. 2 mm and then starting. I think we take a look again. We have here also the start delay on 0.3 and the end delay of 0.3, and here is all together off. Then we see we have here a ball on the wire. Position on the start, 2 mm back, and on the right side is all off. That's a parameter for DynamigWire. You can also take a look to this pulse. Principle is always the same. The wire feeder is working. When you need, you became the wire. When you don't need a wire, then it's not feeding. It's the same when without pulse or with pulse. And on this we see the -5 is meaning less wire and 0 standard, and +5 is you became more wire. Maybe when you have the first pass for the root side, you use -5, and for the next layers, when you want more wire, then you give more wire. This we see. That's a sample, okay, 8 mm. Practical advances from DynamigWire is improved wetting behavior. Excitation of the weld pool helps in case of component tolerances because the feeding regulates amount of filler material when you have the gap is changing or something. Application specific setups, you have some characteristics are available, and simplify manual welding as tolerances and changes in arc lengths. Wire and current no longer have to be set separately thanks to TIG synergic mode. You have not a lot of parameters, it's easier to handle. When you have some welders with less skills, then it's easier with DynamigWire. Wire control and case consequences, you see here some example. We have here beginning 0 gap and here with 4 mm gap. Beginning here, weaving off, and here with weaving on. Wire feeding for manual applications. Have here also what's new is the TFC system, the tungsten fast clamp. It's meaning a pen. When you push the button, you can change the electrode. You don't screw it. When you open this screw, push it back, you can push out the gas nozzle, and with the button on the back side, you can remove the electrode. Also we have the TIG dynamic pen for difficult applications or for pipe welding. When you have no rotation table or something where it's easy to handle for some applications, we recommended the dynamic pen. It's also available. We made also some tests with TIG cold wire and DynamigWire. That is meaning okay. TIG manual with mechanized DynamigWire, you need less skills, And normal with TIG welding, the highest skills in the middle and the lowest skills with DynamigWire. Comparison with the V-seam from the cold wire side DynamigWire. When you look on this picture, you see exactly, okay, the wire feed is always feeding constant. And then you have too much wire inside in the gap. It's always feeding. And on DynamigWire side is always stopping. When you have the contact, it's stopping. On the root side, you see it on the back side. You have some material too much. That's the comparison. Also on the C weaving, on the C side, cold wire, you see, is always changing the contact tip. On DynamigWire side is really also welding a plate. DynamigWire is cold wire, and we have 153 seconds on the DynamigWire and maybe near 200 seconds on the cold wire side. Yeah. That's from the weld cube data management. We see here cold wire energy, put also more energy inside. Yeah. And the time 196 and 153 on the DynamigWire. It's possible to weld faster and less energy. And we have here some oscillation from the weld cube side. You see here it's always the cold wire constant, and here on the DynamigWire is working together. 42 seconds faster welding possible. Always important is when you start DynamigWire, made the AL alignment, the power source must know. We have this function inside. When you have a longer hose back, or when you have the ground cable, or the ground situation is not always the same, then it's important you made the AL alignment. Then the power source know how much voltage you need. That's easy to explain. Process, DynamigWire, change material, whatever you want to use it, and then diameter, gas, and save it. And then you can start. That's here some different parameters. Wire fee setting, DynamigWire. Important parameters are the TIG wire correction, what we see, go to minus or go to plus, then you have more or less wire. The wire start delay, you have the contact, then the arc is burning, and then 0.2 seconds is waiting, and then comes the wire. On the end delay you have also here, on this ramp to the second, so to the delay 2, you have also 0.2 seconds. You can also use how many millimeters you want to back on the end and also on the start. Recommended wire distance, what we say, from this current side, that's the distance to the tungsten electrode. Yeah, universal setting 2 millimeters. Here we see the wire feed speed correction. That is also on the macro side, what we made some tests on here. Wire feed speed correction to -10, you see here the penetration is more. And when you give more, then the wire is always cooling the welding seam, we know about it, and then you have less penetration. Yeah. That's the end of the presentation. Yeah. Now, normally we have demo. Okay. Thank you, guys. Yeah.
Is this, you just plug this into the machine, it's almost like a MIG welder, but you're TIG welding.
It's TIG welding, huh?
Yeah, but it's the same principle as in like a MIG welder. You have a roll that's feeding the wire instead of you holding it.
Yeah.
That's, if I understand it correctly. Yeah.
That he is asking for is the same wire that we use for MIG-MAC welding.
Yeah, yeah.
It's the same wire.
Yeah.
The same wire. Huh?
Okay.
You use the same feeder.
No,
No, it's different.
it's not the same feeder because of the speed of the wire.
The speed of the wire, yeah. And we have here also, you see, it's also a cold wire feeder. That's the principle how it's working. Yeah. It's a measurement from the voltage. And we have here a V volt print inside in the wire feeder. That's the measurement, and here is the point to measurement the voltage of the wire. That's the point of the DynamigWire.
That's why you have to calibrate the machine.
Genau. It's always important to make the AL alignment. When you have 2 meter longer hose back or other situation from the weld, from the ground cable, then you have different values from the ground side. And then it's feeding more or less, then it's not working. Huh?
And then the machine, thinks for you, it sees I'm not getting enough wire, and then it pushes more.
Yeah.
And if it's getting too much,
Then it's not really good working. Yeah.
but the machine is, thinking
They
and
are measuring, he is asking, they are measuring the voltage.
Yeah.
All the time.
it's always measuring the voltage, and then according to the voltage
Yeah.
they're putting.
And the voltage measurement is working with this, yeah? With these prints and with this working. Yeah? And it's the measurement point is always here.
Yeah.
The voltage between the workpiece and the wire. And when you have made the element once before you start, then you have always the same values, yeah?
Perfect.
Okay? Any questions? All clear. Thank you guys. Yeah? Thank you.